Hey everybody, we're practicing factoring here. So remember, the first thing you'll do is take out a greatest common factor if one exists. And number one, I don't see a greatest common factor. That's too bad. So if we only have two terms in the polynomial that we're trying to factor, we're going to think difference of squares or difference of cubes or sum of cubes. In this case, it's difference because we're subtracting, and while 64 has a square root, x to the third is not really square rootable, and 125 is not square rootable. So I'm going to think difference of cubes. Can I cube something to get 64? And x to the third, yeah. 4x cubed is 64x to the third. And can I get something, can I take 5 to the power, or can I take something to the power of 3 to get 125? And yes, it's 5. So these are my cube roots, 4x and 5. So now, because it's the difference of the two cubes, I'm going to, this is my a value right here, 4x. And 5 is my b value. So I will substitute those values in for a and b respectively. So this is what my problem looks like in standard form. This is what it's going to look like in factored form. So instead of a, I'm going to have 4x minus 5 out in front. So I'm done with this part. Now I have to square my a term, so I have to square the 4 and square the x. That's 16x squared. And then I add the product of a and b, so 4 and 5. 4x times 5x is 20x. And then I add b squared, which would be 25. So this is my factored form of that problem. For number 2, I'd be thinking of the same thing because there are two terms, except for always look for a GCF. So I can factor a 2 out of each of those terms. And so now I'm sitting with 2 times the sum of x to the third plus 8. So now I'm going to try to factor what's inside the parentheses more. And again, it's two terms. So I'm thinking difference of squares, difference of cubes, or sum of cubes. And because we are adding the two terms, it means the sum. So I'm hoping I can cube root x to the third, and I can because x raised to the third power is x to the third. So x is the cube root of x to the third. And can I raise something to the third power to get 8? That's 2. So I'm going to use this template, the sum of cubes, and I now know that my a value is x and my b value is 2. So I'm going to go x plus 2 times my a value, which is x, squared, minus my a times my b, so x times 2, which is 2x, and then plus b squared. 2 squared is 4. But however, do not forget this 2 out in front. Remember this GCF of 2 that we factored out in front? That has to come down. So here is my final answer. Beautiful. Next one. So we have subtraction, and we have two terms. By the way, first look for a GCF. There is nothing that I can factor out. There's no number that goes into 16 and 81. And notice this doesn't have an x term, so I can't factor x's out of both of them. So there is nothing that I can cube that becomes 16, but there's something I can square to get to be 16. Yes, 4 and x squared equals 16x to the fourth. And I can square a 9 to become 81. So in other words, both of these terms are square rootable, and the square roots are 4x and 9. Now when it's the difference of squares, remember we add the square roots and we subtract the square roots. Check it out, if you FOIL this back together, you get what we started with. Sweetness. Same thing here. There's nothing we can GCF out, so I'm thinking difference of, because it's subtraction, difference of squares, difference of cubes. You know, 4 cubed is 64. But can I take the cube root of x to the fourth? It's it's not going to leave me with something pretty. So I'm going to try square rooting, excuse me. X squared gives me x to the 4th. And 8 squared gives me 64. So this can be broken down into the difference of squares. So I have x squared plus 8 and x squared minus 8. And if I FOIL that back together, I will end up with x to the 4th minus 64. Number 5, there is nothing I can factor out of all of 4 of the terms because this one doesn't have an x and this coefficient is 1, so I can't factor anything other than 1 out. So then count the number of terms. If it's 2 terms like we've seen for the last 4 problems, it's going to be difference of squares or cubes or the sum of cubes. When it's 4 terms, we're going to think factor by grouping. So I'm going to hug the first 2 and I'm going to hug the last 2. Now when I hug the last 2, it's really important that if the third term is negative, that third term has a minus sign in the parentheses. So then we try to factor out the most that we can out of these first 2 terms. I can factor an x squared out of both. That leaves me with inside x plus 2. Then factor the most that you can out of here, but keep in mind that what's left in the parentheses, what's left in the red parentheses, should match perfectly what's left in the first or blue parentheses here. So you might be thinking I can factor 40. Did you realize that 49 goes into 98? 49 times 2. So you might be thinking, well, I can factor a 49 out of both of these terms. And that's a good idea, folks. However, when we divide by 49, we get a negative x, and we divide negative 98 by 49. Oops, I just gave it away. When we divide negative 98 by 49, we get a negative 2. And that's opposite. Both of those are opposite of what I actually want. So instead I'm going to divide by a negative 49, which means I'm actually factoring out a negative 49. So then I get positive x and positive 2. Check this out. If I were to distribute this back in, I get negative 49x and I get negative 98. So I've correctly factored, and also equivalently, it isn't just as important with factoring 4 terms, what's left in the parentheses has to match up. So then I can factor one more time. I'm going to factor an x plus 2 out of each of these terms. And when I say each of these terms, remember terms are things that are separated by addition or subtraction. So here is a term and here is a term. Notice in the green and the blue, one of the factors is x plus 2. So I'm taking it out here, and I'm taking it out here, or factoring it out. So then to figure out what's left in the parentheses, you divide. So this x plus 2 cancels out, and I'm left with x squared, and the x plus 2 cancels out there, and I'm left with negative 49. So that's a good answer, except for, remember, just like, where was it? Up here, once we did a GCF, we wanted to try to factor what's left in the parentheses a little bit further. And you can do that here because this is a difference of squares. The square root of x is x, the square root of 49 is 7. So this is actually equivalent to x plus 7 times x minus 7. And then I drop down the x plus 2. This is the best answer right here. And again, this came from factoring that difference of squares. Number 6. Now always look for a GCF, and I realize that there's an x in all of the terms, and there's a 6 that is also a factor of each of the terms. So I'm going to factor out an x, 6x from each of these, which leaves me with x to the 3rd. So all these exponents are going to get reduced by 1 power because I'm taking 1x out of them. So that leaves me with x to the 3rd, and then 6 times 2 is 12, and I'm taking an x out of there, factoring an x out, so it leaves me with x squared plus 2x plus, and then 6x times 4 is 24x. Cool. Now I have 4 terms left in there, so I'm going to try to do factor by grouping. So I'm going to keep on bringing down that GCF, the 6x, and then I can factor an x squared out of this first set of parentheses, so I'm left with x plus 2. And then out of the second set of parentheses, I can factor out a 2. And realize when I do that, I'm left with x plus 2. And notice that what's left in the parentheses matches. So I'm going to factor an x plus 2 out of the green term and the blue term. And when I factor an x plus 2 out of this term, I'm left with x squared. And when I factor an x plus 2 out of this term, I'm left with a 2. And then I'm not going to forget to bring down the 6x. Look inside your factored form. Can you factor any of these by any of these parentheses factors any further? No, I cannot. So I'm done.